Hi everyone, today we're going to be looking at the protocols chapter. It's chapter 4.1 in the app development with Swift textbook. Let's get started. Okay, create a human class with two properties, name of type string and age of type int. You'll need to create a member-wise initializer for the class, initialize two human instances. Okay, that's pretty easy. So let's go ahead, class, and we're going to call it human. And that's essentially it. We're gonna have two variables here. So var name of type string and var age of type int. Beautiful. And then we're gonna you'll need to create memorize initializer for the class. Okay, so we need to do that. So we're gonna go init, right? And we're gonna say name, it's gonna be of type string, and age is of type int. All right, that's pretty much it. And then we're gonna say self.name equals name and self.age equals age. All right, and that should be it. Cool. And then says initialize two human instances. Okay, we can do that. So let's have a look at. I'm gonna call it let human 1 equals human, and I'm gonna give it a name of for the sake of logic age 31, and let human 2 equal human and the name for the sake of logic 2 age 32. Cool. All right, make the human class adopt to the custom string convertible. Print both of your previously initialized human objects. Okay, so we need to go back here, and to do that all we have to do actually is add this thing right here, custom string convertible. And it's gonna say, well, this doesn't conform, because what we need to do is we need to do a description, right? Because that's what that protocol requires. So we're gonna go var description of type string, and we're gonna say return, and it's gonna return a string. The string, when we print one of these, the string, we could say it's customary to make it look like an initializer. So you could obviously type whatever, but I'm gonna type in human, and I'm gonna say name, and then I'm gonna use string interpolation name, and I'm gonna go age, age. Okay, so essentially this is telling you what to print when you're printing this class. I could have done anything here, right? So I could go anything here, right? It doesn't matter, but it's customary just to do this. It kind of looks like an initializer, you'll see. So if I go ahead and print human 1, for example, and print human 2, if I do that, it'll actually print properly here. Give it a second, it's running, there you go. It prints, it looks pretty cool, right? Starting from here, obviously it prints this because I added this in the string. So I'm gonna go ahead and delete this. I'll show you what it's supposed to look like. This is sort of like industry standards. So it kind of looks like an actual initializer, and obviously I forgot this. There we go. Now it looks professional. All right, cool. Make the human class adopt the equitable protocol. Two instances of human should be considered equal if their names and ages are identical to one another. Print the result of a Boolean expression evaluating whether or not your two previously initialized human objects are equal to each other using the equal. Then print the result of a Boolean expression evaluating whether or not your two previously initialized human objects are not equal to each other. All right, let's have a look. So how do we do that? So to make it to do a comparison, we have to do the equitable protocol, and literally you just type that in. Cool. Now we're gonna have an error here in a sec that says, well, your class doesn't really conform with equitable. Just give it a second. It should eventually say, there you go, type human, right? So my class human doesn't conform to equitable. Why? Because I need the equitable stub. So I could go ahead and actually press fix and it'll add it for me. And essentially I need this static function that compares left hand side with right hand side. Okay, so let's have a look at what to do here. In here, all I'm doing is I'm just gonna say return left hand side, right? That's what LHS stands for. Name equal right hand side dot name, and a left hand side dot age equal right hand side dot age. So essentially I'm returning I'm saying that this the left hand side of the name, whatever the name is, and the right hand side of the name have to equal each other, and the age have to equal each other as well. The reason I'm adding both is because it literally told me here two instances of humans should be considered equal if their names and ages are identical. If it only wanted names, then I wouldn't have to put the dot age. Cool. Print the results of a Boolean expression evaluating whether or not the two previously initialized human beings are equal. Okay, let's have a look at how we could do that. So we're gonna go ahead and print, and I'm gonna say human1 equal human2, and the result should be false because it returns a Boolean, and surely enough it's false. Why? Because human1 and human2 have different attributes, right? Different names and different ages. If I print human1 not equal to human2, that will obviously give me a true value. Let's go ahead and look at that. Surely enough, it says true. All right, pretty cool. Make the human class adapt to a comparable protocol. Sorting should be based on age. Creating another 3 instances of human, then create an array called people of type human, array of human rather, with all the human objects that you have initialized. Create a new array called sorted people of type human. That is the people array sorted by age. All right, that's a mouthful. Let's see what we could do here. So the first thing that we have to do is we have to make it comparable. Cool. And what we have to do now, again, is gonna throw an error at us. And the reason it throws an error is because we have to add a stub for comparable, and it's one static function, and it's the less than. Now the less than, let me explain something. When you're comparing something, you don't just use less than, you use less than or equal to, greater than or equal to. Just by doing this, Swift is pretty smart. It can figure out the rest. Cool. So what do we do here? Again, there's a left hand side and a right hand side, and it throws out a Boolean, essentially true or false. Okay, so what do we do? Right hand side dot age. Well, hold on, we're returning this. Return left hand side. Let's always begin with always left hand side less than right hand side dot age. Okay, so we're returning the left hand side age and the right hand side age. Okay, and we're saying it's less than. So it's going to compare these two things, and then I'll be able to compare less than and greater than everything else. The reason I'm only comparing the age, because it's going to sort it, right? The reason I'm only doing age is because it literally only asked for age. Where is it? Right? It should be based on age, right? So if it were based on name, which we could do, you could easily compare strings, but it asked us for age. Cool. Then it says, then create an array called people. Okay, let's have a look at this mess here. Create another 3 instances of human, then create an array called people of type human array with all of the human objects that you have initialized, so all 5. Okay, let's do that one thing at a time. So let's create let human 3 okay, equal human, and we're gonna go for the sake of logic 3, and this is gonna be 33. Cool. And let human 4 equal human, and it's gonna be for the sake of logic 4, and this is gonna be 34. Not sure why it's missing all these brackets, to be honest. And we're gonna create let human 5 equal human, not human, human, and we're gonna do, yeah, it keeps missing the brackets. Probably some sort of glitch in Playground. For the sake of logic 5 and age 35. Cool. So we've created 5, we've created these 3, and we've created 2 over here. Fantastic. Now what we're gonna do is, it tells us to create a wrong place. Tells us to create a an array called people, var people, right? Of type human, and we're gonna initialize it with the following: human 1. I'm not gonna do an order just so that I could show you that it'll actually sort, just in case we need to sort it, which I think we will have to. Human 4, human 5 I did, human 2 I did not do, and human 3. Right, so we've got 1, 2, 3, 4, 5. Beautiful. Okay, create an array of human, that is people. Okay, I create a new array called sorted people of type human. Okay, so we're gonna go var sorted people. Also, it's an array of humans, and create a new array called sorted people of type human, that is the people array sorted by age. Okay, so right now it's empty, so I'm gonna put all of this in here except sorted. So how do we do this? So this array is called people, so we're gonna sort people. So people dot, check this out, sorted, and then, no, wrong one, we're gonna sort by sorted by, yeah, there we go, this is it, and I'm gonna go just like that. So by least to greatest. So if we print, if I print sorted people, it should give me, I'm not sure what's happening here. Import foundation, expected, yeah, this error wasn't here before. Oh, this thing keeps missing a parentheses, huh? And it's not even in the right place there. Anyways, not the point. Let's look at this. So when I printed this, what does it show? For the sake of logic, for the sake of logic 2, for the sake of logic 3, for the sake of logic 4, and for the sake of logic 5. Why? Because I sorted it by less than. So sorted people took this array, which is obviously unsorted, and it sorted it properly. If I change this to this, it's going to sort it from largest to smallest, or 35 to 31. And surely enough, 35, 34, 33, 32, 31. Pretty cool, eh? All right. Awesome. Almost done here. Make a human class adopt to the Codable protocol. Create a JSON encoder and use it to encode as data one of the human objects you have initialized. Then use the data object to initialize a string representing the data that is stored and print it to console. All right, let's see how we're gonna do something like that. So the first thing that we gotta do is we gotta make this adopt to Codable. So to do that, it's pretty easy. So we go Codable, and that's essentially it. Now we don't actually need anything here. Let me just think here for a sec, because we've got Yeah, yeah, we don't need anything here actually. Codable already, because everything inside of here, strings and integers are structures made by Apple in the standard Swift library that already conform to codable. So we don't need to do anything here. All right. So what do we do here at the bottom? So make a human class adopt the codable protocol. We did that just by adding the word protocol, adding the word codable. Create a JSON encoder and use it to encode as data one of the human objects you have initialized. You really learned this in you learn more about this in chapter 4.7. So if this is going to confuse you, I highly recommend reading chapter 4.7. But I'll show you how to do this. I'm going to call it my encoder, for example. I'm going to call it my JSON encoder just to differentiate it from a different type of encoder that I usually use. Encoder equals JSON encoder, right? Cool. So I created an instance of JSON encoder called my JSON encoder. Cool. And I'm gonna say let data, right, or whatever, where we're gonna store the thing, equal try. I'm gonna force this, and I'm gonna go JSON encoder. No, we're not gonna say JSON encoder. We need to use the instance I made. So my JSON encoder dot encode, and we're gonna encode the value. Let's encode I don't know, human4 as an example. Human4. So now we've taken human4 and we've encoded it using JSON encoder, right? My JSON encoder, and we've saved it in this variable called data. Now if I option click, it's going to show you data is of type data, right? So I'm just going to call this my data just so that you can differentiate it, right? So my data is a variable of type data. Cool. And then now I'm going to say let's see here. So when you encode something, this is going to be tricky because now we have to encode it. But what I'm going to do is I'm just going to print it as a string for now. This is technically not necessarily right, but I'm just going to do this. I'm just going to do this for the purposes of showing you that this actually works. Okay. So if we do this, it goes ahead and actually prints the fourth one, right? It prints the fourth one. So what I'm trying to show you here is just in case, just to prove to you that this actually got decoded and we're printing it here. So human4 got encoded. Actually, let me show you this just to illustrate what happened here. So if I go print my data, and this is of type data, you'll see what actually gets printed. And what gets printed here is merely the size of it, right? So 38 bytes. If I added more info here, so I'll show you human4. I'm just gonna add more info here. And I press this should be larger, right? So 38 went to 65 bytes. So now there's more data that got encoded. So when I do this, I'm actually encoding something and saving it to data, right? There's a variable that's of type data, and I'm printing it. It doesn't print the data, it just prints the size. So what I'm doing here is I'm actually not decoding it here. I'm not decoding it. What I'm doing here is I'm just printing the string version of the data using this string method. This is not a method. This string universally accepted way of writing strings, I guess, is the best way to say this. If you do any sort of web development, that you know a lot of text is written in this format. Anyways, and I'm printing the string. So that's page 1. If this part really confuses you, you'll learn more about this later in the book, in chapter 4.7 and later in chapter 5 when you're dealing with web in the book. All right, let's move on to page 2. All right, page 2. Let's have a look here. The workout objects you've created so far in app exercises don't show a whole lot of useful information when printed to the console. They also aren't very easy to compare or sort. Throughout these exercises, you'll make the workout class below adopt certain protocols that will solve these issues. So let's have a look. The first thing that they want us to do is make the workout class above conform to the custom string convertible. So we've already done all of this, but I guess we'll do it again just to make it easier. So again, it's going to throw an error. We need the stub. Essentially all it is, it's a string, right? And I'm actually gonna cut this and I'm gonna put it after the initializer. How about that? Cool. And I'm gonna return, we're gonna return a string, and we're gonna return, this is my workout, and we're gonna go the identifier, yeah, I'm not sure why this is not seeing it. It should see it, to be honest. Am I doing something wrong here? So let's go distance. There we go. That took a while. And time and identifier. Cool. So if we go ahead and print something like this here, make the workout class conform so information, create an instance of workout, give it an identifier, and then print the console. Okay, so we're gonna go var my first workout of type workout, and we're gonna initialize it with a distance of 100, time of 12, and identifier of 1. And if we print my first workout, it'll print essentially this text right here. Cool. All right, probably not, this is not proper, this is not proper like writing convention, but it's something, right? Just showing you how to do the description part. Cool, let's move on here. Make the workout class above conform to the equitable protocol. Two workout objects should be considered equal if they have the same identifier. Create another instance of workout, giving it an identifier of 2, and print a Boolean expression that evaluates, which essentially will say no. Okay, let's have a look at how we're going to do that. So equitable, beautiful. Again, it's going to say it's missing a stub. Instead of actually just pressing fix, I'm going to type this one out just to show you. So I could press fix, it'll type it out for me, but I'll show you how easy it is to type it out. So it's static, right? Func, it's a function, equal, open parentheses, and it's left hand side, right? And the left hand side is a workout, right hand side also workout. And this function returns a Boolean, and that's it. Now inside here, we're going to return left hand side dot identifier equal right hand side dot identifier, and that's pretty much it. So what do we do here? What we're going to do is we're going to make another workout. So we're going to go var my second workout equal workout, and we're going to initialize this with, I don't know, 225 and an identifier of 2. And here we're going to print first workout equal my second workout. And if we do that, it should spit out false. And surely enough, it does, because these are false. But if I change this to 1 and I print this, it should say true. And surely enough, it does. Cool. So that's pretty easy. Okay, make the workout class above conform to the comparable operator, so that you can easily sort multiple instances of workout. Workout objects should be sorted based on their identifier. Create 3 more workout objects, giving them identifier 3, 4, 5 respectively. Then create an array called workouts of type workout array, and assign it to an array literal with all 5 workouts objects you have created. Place these objects in an array out of order. Then create another array called sorted workout array. Essentially, we're doing exactly what we did on page 1. So let's see how we're going to do this. Again, we're going to do comparable here. Cool. And we need the stub for it. This time I'm just going to have Xcode build it for me. I like my stubs to be at the bottom here, just to be in order here. And in here, it's pretty easy. All we're going to do is return left-hand side dot identifier less than right-hand side dot identifier. Cool. And if we do what they're asking us to do here, we have to make how many? 3 more. So var my third workout equal workout, and we're gonna go 300 times 35 identifier 3 var my fourth workout equal workout, and distance is 400 45 4, and var my fifth workout equal workout, distance is 500 55 seconds, and an identifier 5. Cool. And then what else are they asking us to do? Create an array of workouts of type workout. That's easy. Var my array of workouts, right, equal it's of type workout, and I'm gonna initialize it with the workout out of order, right? Place the objects in the array out of order. Okay, so let's do that. Let's go with fourth, and then we'll go with second, and then we'll go with first, and then we'll go with fifth, and then we'll go with third. There we go. Cool. So first, second, third, fourth, fifth. Great. And then we're gonna say var my sorted workouts equals, right? We're gonna say my array of workouts dot sorted by, and we're gonna go by less than. So it's gonna go from least to highest. I have to print it, obviously. Print my sorted workouts. No. My sorted workouts. And it's gonna go from the least to the most, obviously. 1, 2, 3, 4, and 5. If I do this, it's gonna go from highest to smallest. 5, 4, 3, 2, and 1. All right, works perfectly. Okay. Again, same thing here. Make a workout, adopt the Codable protocol. Cool. So let's do Codable, and we don't need to add anything in there. So make a workout Codable protocol so you can easily encode workout object as data, then can be stored between app launches. Use JSON encoder to encode one of the workout instances, then use the encoded data to initialize a string and print it to the console. Just letting you know, this is like a cheap way of doing it. This is not the right way of doing it. You're merely printing a string version of the data. What you usually do is you decode what is encoded. You decode the data, and then you take that decoded data and place it in a variable to use again for for persistence data as an example. So this is not necessarily the way you do it. Essentially, it's the same way that we did this. So I'm going to do this real quick here, okay? So we need to import for that foundation, which they already did for us. So var my encoder equal JSON encoder. Cool. And let my data, I don't even know why I made the first one a var. That's fine though. Let my data equal try my encoder dot encode. And what are we encoding? Let's encode, I don't know, the third one, right? So I'm gonna go third workout. So we're gonna encode this third workout. And what we're gonna do here is I'm gonna create a new string. I'm gonna call it my string, and we're gonna give it a string that is of my data. So I'm gonna go what do I do here? What do I do? So I'm gonna go data, my data, and we're gonna go encoding, and it's gonna be .utf8. Cool. This should work, and I'm gonna print my string. There we go. Cool. Value has no member encoded. Did you mean encode? Yes, I did mean encode. No, I mistyped that. All right, that's fine. Cool. And if I print out my string, it should print out data, 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 right? And this is an optional because it might not have something in there, right? Cool. All right, let's move on.